Sharp 9 p.m. in India. Let's respect time. Let's start. Hello everyone. Good evening. Am I audible? Please confirm in the chat. Am I audible? Audible. Yes, sir. Yes, 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 sir. Yes, sir. Great. Thank you so much for the confirmation. And 40 people have joined, and I am expecting you all had joined the yesterday class as well, right? You all were there in the last class. So guys, let's confirm this as well. If you were there in the last class, then just type yes in the comment section, and if you are joining this class for the first time, the VPN Bootcamp says first time, then type no. Let me see, is there anyone who is joining today only? No, no, yes, 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 lots of yes. No, no. So few people has not joined the last class. So in the last class, brother, we had discussed about basic terminology of VPN, like what is VPN, why we need VPN, and then we had talked about the GRE VPN. Again today I will start with the GRE VPN, and after that we'll see other types of VPN. To understand the foundation, GRE VPN is so important, right? All the VPNs, other types of VPNs are based on GRE VPN only, whether it is service provider based VPN or customer based VPN. In last class we had seen we have categorized the VPN into two sections: service provider and customer based VPN. So my GRE VPN is customer based VPN. Customer engineers are going to configure it, manage it. Today we'll see the implementation of GRE VPN. After that I will show you GRE VPN is not secure, so we'll implement IPsec to secure that. Again, in IPsec there are so many security terms, I cannot discuss all, but I will try to cover as much as possible, like encryption, integrity. I'm assuming that you guys are familiar about these basic terms of security, right? Confidentiality, integrity, right? Authentication. Authentication means who are you, right? Do you have the password and username, right? The method to identify the user is authentication. Integrity is only authorized person should be allowed to access my data, right? Only the company employees should have access of my data. So we can achieve integrity with the help of encryption. And then confidentiality means no one on the network should be allowed to modify the data, right? Attacker should not be allowed to spoof your data. Only authorized users should be allowed to modify the data. And how we can achieve it? With the help of hashing. So these are basic security terms. I am assuming you all are familiar with these all basic terms. What is encryption, what is hashing, and what is the authentication. If you know the AAA server, in the AAA server we are also using the same method, the authentication method. In the IPsec, actually, you know, in the IPsec we have two phases, right? Phase 1 and phase 2. When it's come to secure the VPN data, yesterday also I told you VPN isn't mean security. VPN means just forwarding the private data over public network. Means how two or more private site can communicate with each other over public network. That is VPN. But VPN does not provide any kind of security. For an example, GRE VPN is not secure. Your data is going to travel in plain text. Anyone can capture the link by using the caption tools, and they can read your data. MPLS L3 VPN, again not secure, right? Even MPLS means service provider network is public network connecting various companies network together. So by default, service provider is not going to provide you any kind of security. MPLS is just a reliable transport between multiple sites. There is no any security by default. For the security, I can use get VPN there to secure the GRE or DM VPN, or even your remote access VPN or SSL VPN. You can use IPsec. Can anyone tell me the difference between SSL VPN and remote access VPN, guys? What is the difference between SSL VPN and remote access VPN? Purpose of both the VPN is exactly same. My remote user, how my remote user can get connected with my corporate network from their home, their cafe, from the airport, right? While traveling even. Purpose is same of both the VPN. But before starting this today's session, we'll start from the GRE. But before that, let me ask you some questions. It will help me to understand from where I should discuss in the class. Hi sir, I am your channel members. Yes Ramesh, I am able to see you are the member of PM Networking YouTube channel. Thank you so much for subscribing and for becoming the member. You are the family member of PM Networking. Tell me how I can help you. I want to learn CCNP full playlist day by day. Sir, CCNP full playlist is not available on YouTube. Even I cannot upload the complete video of any course on YouTube, right? In many live session I have talked about the reason behind it, why I'm not uploading the complete course on YouTube. Please create one playlist for CCNP in core and NRC playlist. No brother, I cannot create the complete playlist for CCNP in core and NRC. I am launching a batch of CCNA plus CCNP combo where I will cover these three papers: CCNA 200301, CCNP in core, and CCNP NRC. You can register for that batch. Yes, so I am expecting some answer from you guys in the comment section. Tell me the difference between the SSL VPN and remote access VPN. Currently we don't have any notebook on subjected class. It could be better if you have a notebook. We'll share the notebook in your WhatsApp group. Sir, please day by day class. Yeah, recording will be also available. So I think no one has idea about the SSL and the difference between SSL and remote access VPN. No problem at all. What is GRE VPN? GRE VPN is a simple tunneling between two sites over the IP. Simple tunnel or VPN over the IP network, that is GRE. Not encryption, only encapsulation. There is difference between encryption and encapsulation. Encryption means changing the data, and encapsulation means adding the extra information with data. Encapsulation is similar like when you are putting your letter in envelope. That is what one kind of encapsulation. And encryption means when you are encrypting I love you into 143, right? We often use this encryption in our day-to-day life. 143, right? So that is encryption. So your GRE just offer encapsulation, not encryption. To achieve the security, what you can do, you can implement the IPsec. Again, to implement the IPsec, you have to configure IPsec in two phases. In phase 1, ISACamp, and in phase 2, the IPsec. Phase 1 is responsible to secure our tunnel. And phase 2 is responsible to secure our data. Phase 1 is not used to share the data, right? User data. I'm talking about data plane. That is just to establish a secure channel between 2 points. Phase 1, ISACamp, right? And ISACamp is protocol suites, combination of multiple protocols. Like ISACamp uses IKE protocol. Again in IKE we have two versions, IKE version 1, IKE version 2. Again in IKE version 1 we have two modes, the main mode and quick mode, right? So these are different small concepts of IPsec which we are using to secure our VPN. Similarly, to secure our remote access VPN or any GRE VPN, we can use IPsec. What is the difference between site to site VPN and IPsec? IPsec is not VPN. IPsec is tool to secure our VPN. It offers the security features. Palo Alto full playlist available on the channel. Palo Alto configuration playlist is available on the channel, brother. That is not a full course. That is not Palo Alto course. You will find the Palo Alto course on my website. On the YouTube, there is one playlist for Palo Alto. You will find the configuration of Palo Alto firewall only. Okay, so guys, let's begin the session. Let me share my screen and hope yesterday class is clear. For those who are joining me today, for those guys, GRE is nothing but the simple tunneling between 2 points over IP. Is my screen visible? Please type in the chat whether you are watching me on YouTube, Facebook, or here connected in Google Meet. Yes sir, yes sir, yes sir. Okay, great. Thank you so much for the confirmation. What about the guys who are watching me on YouTube? Is my screen visible? The topology is visible for you? See here, in my topology there are two sides. You can assume side 1 and side 2, headquarter and branch 1. Here I have one more topology, another topology, this one. Here we'll see remote access VPN configuration. You can see here I have one remote user. This remote user is, let's suppose, working from the cafe or working from their home or working from the airport, and this is my corporate network. So I want this remote user should be able to connect with my corporate network securely. We can configure either SSL VPN or we can implement here remote access VPN. Between the user and your router, you will create SSL VPN or remote access VPN. I have asked the difference between SSL VPN and remote access VPN. Guys, for remote access VPN, tell me, this remote user, home user, need to access any application, need to configure their laptop for VPN, for remote access VPN? Answer is yes. Right? VPN client is required here. VPN client application is required. That means VPN configuration is required on the client machine. But in case of SSL, this remote user can even connect with my corporate network through browser. Right? Remote access VPN is similar like the online shopping, and SSL VPN is similar like the shopping from Amazon, right? From a dedicated application. I will come here again. First, let me discuss the GRE VPN here. Sir, are you going to cover IPsec as well? Yes, first we'll implement the GRE, and then to secure the GRE we'll configure IPsec. I will show you the configuration for IPsec. Yes, any connect is required. Correct. Absolutely right. Jisan, you are absolutely right. But for SSL VPN, no any VPN configuration is required on the client machine. Now, on my router number 1 in side 1, I am assuming this is side 1 or headquarter or branch 1. Let's say this is branch 1 and this one is branch 2. In branch 1, my public IP address is 1.1.1.1. In branch 2, my public IP address is 2.2.2.1. First of all, we'll verify that these two public IP addresses are reachable with each other or not. and as both are public IP address, I am expecting both should be reachable with each other. Let me take you to router number 1 and let's ping 2.2.2.1, ping 2.2.2.1. There is no reachability. I am not able to ping. Now question, why I am not able to ping? Let's verify it. Let me check the configuration, basic configuration. So IP interface brief exclude unassign, and here you can see IP address on fast Ethernet 0/0 is 1.1.1.1. This is absolutely right. And on router number 2, so IP interface brief exclude unassign. Here also on F0/0 IP address is 2.2.2.1. Correct, right? So run interface F0/0. Submit mask is 255.255.255.0. Let me ping my ISP IP address, means gateway IP address 1.1.1.2. Dot 2 is running on ISP side, dot 1 is running on my edge router. So you can see I'm able to ping the gateway IP address. My ISP is reachable from me. /24, yes. My ISP is reachable from R1. Let me check from R2. Is my ISP reachable? Ping 2.2.2.1. And yes, sorry, this is my IP address dot 2. Correct, reachable. Done. From both sides, R1 is also reachable to ISP, right? Able to ping the internet router. R2 is also able to ping the internet router. Then why these two public sites are not reachable? These like two public IP addresses are not reachable. Let me check the route. So IP route and 2.2.2.1. What it's saying, network not in table. There should be one default route, guys. Even for NAT, to access the internet to a ping 8.8.8.8 from this PC, I have to configure one default route, right? So let me check default route is configured or not here. So IP route is static. No, there is no any default route configured. Let me configure one static default route. IP route 0.0.0, 0.0.0, F0/0, and next hop IP address 1.1.2. Go to router number 2 and let me configure one default route here. IP route 0.0.0, 0.0.0, and exit interface F0/0, and next hop IP 2.2.2.1. Not 1, it should be 2. Very good. Now I have configured the static default route on both the router, on router number 1 and router 2. Both are my edge router. From router number 1, if I am going to now check the routing table 2.2.2.1, still network is not in table, but so IP route is static. This time I have one static default route, and this is the gateway IP address. From router number 2 also, so IP route is static. I have one static default route, and this is the gateway IP address. Now let me check these two public IP addresses are reachable or not. Ping 2.2.2.1, and now you can see it is reachable, right? Branch 1 public IP and branch 2 public IP, both are reachable with each other. I'm able to ping. Now with the help of these two public IP address, I am going to create here VPN. I'm going to create VPN, and for the VPN, guys, what I will do here, for the VPN, I will create tunnel both sides. VPN both side, I will create one tunnel interface. Tunnel interface, tunnel 1 and tunnel 2. And on the VPN, let's suppose my subnet is, on the VPN is 172.16.1.0/30. 0/30. This is my subnet on this virtual private network, right? So let's create one virtual private network here, and then we'll run this subnet here. Go to router 1 and create one tunnel interface, virtual interface, and then tunnel, and after that tunnel interface ID. You can see the range of tunnel, how many tunnel you can create on router. I'm going to create tunnel 1, and let me say IP address 172.16.1.1, 255.255.255.252. Go to router number 2 and let me create one tunnel here as well. Interface tunnel 1 and say IP address 172.16.1.2 255.255.255.252. Very good. Go to router 1 and check the IP configuration. So IP interface brief. So IP interface brief exclude unassigned. You can see I am not able to see the tunnel interface in unassigned in the assigned interface, right? Means tunnel interface is still not assigned. So IP interface brief, here is your tunnel interface, you can see. Why? Because their line protocol is, guys, what? Their line protocol is down. Now who will tell me why the line protocol of my VPN is down? Why line protocol of my tunnel interface is down? So IP interface brief. Here also you can see tunnel interface status is up. You don't need to run no such command. This is virtual interface, logical interface. Logical interface will be always up, right? Manually no such command is not required, but their line protocol is down. Why line protocol is down? Why line protocol is down? Do so run interface tunnel 1. Here is my tunnel 1 configuration. Just I have created the tunnel interface and define the IP address, but the line protocol is down. Why? The physical interface is down. Where is the physical interface, brother? This is logical interface. IKE, no other side. No other side, nothing like that. Google public DNS 1.1.1 any connect. Reason why my line protocol of tunnel interface is down is the tunnel source and tunnel destination. You have not defined the tunnel source and tunnel destination. Do so IP route. You can see this router has not installed this network tunnel, the subnet which is running on tunnel interface in the routing table. Until and unless the line protocol is down, it will not install in routing table. And if it has not installed it in routing table, it cannot forward any traffic. Tunnel is not having route path defined. No need to configure route path for tunnel, right? Just we need to define tunnel source and tunnel destination. Tunnel source. Why? Because I am telling to router number 1 that, hey router, see, I have created one logical interface which is tunnel 1 interface, and whenever you want to forward traffic from this tunnel interface, every time source IP address should be this public IP address 1.1.1 and destination IP address should be again public IP address 2.2.2.1, right? So let me say interface tunnel 1 again, and this time I am saying tunnel source. Tunnel source is fast Ethernet 0/0, means whatever IP address is running on fast Ethernet 0/0, that will become your source IP address. And tunnel destination, for tunnel destination I can define the IP manually 2.2.2.1, 2.2.2.1, and now you can see my tunnel interface is up. Now my tunnel interface is up. Sir, please set up P2P BGP tunnel setup. No bro, I didn't get you. P2P BGP tunnel setup means. Now my tunnel interface is up here. Similarly on router number 2 also, if I am going to define tunnel source, which is my fast Ethernet 0/0 IP, and tunnel destination 1.1.1.1, here also my tunnel interface will come up. You can see my tunnel interface is up. Now if I will show you the tunnel configuration, so run interface tunnel 1. So here you can see the configuration. On tunnel 1 interface, just I have defined the IP address, I have defined the tunnel source and tunnel destination. On router number 2 also, so run interface tunnel 1, IP address, tunnel source and tunnel destination, and now my tunnel is up. So IP interface brief. You can see status is up, line protocol is up, right? Even I can filter the output, exclude, unassigned. Done. You can see 3 interfaces are configured here. Very good. Now my tunnel interface is up. Okay, question. If I am going to ping 172.16.1.2 from router number 1, will ping work? Will ping work? Type yes if you are thinking yes, ping will work. Say yes, type yes or Y. If you are thinking no, then type no. And many people are saying no, no. Mustafa, no. Yes, yes, no. So whoever are saying yes are absolutely right. Whoever are saying no, you are wrong, boss. Because now ping will work. As the tunnel interface is up, their line protocol and status both are up. Now we can ping. If I am going to ping, let me show you. Ping is working. You can see success rate is 100%. I had sent 5 packets and I got reply for all the 5 packets. And here you can see the delay in millisecond. Ping is working. But when I ping to this IP, ping 172.16.1.2, source was first my router has generated the ICMP packet. After that, ICMP packet is encapsulated into IPv4 header. In the IPv4 header, source IP will be 172.16.1.1 and destination IP will be 172.16.1.2. Then protocol value will be what? 1, because this is ICMP packet. Upper protocol is ICMP or the payload is ICMP, and then TTL value will be 255. This is my actual packet, but as exit interface for this destination is tunnel interface. As exit interface for this tunnel is this destination is tunnel interface. How many IP pair in the final packet? 2. As the exit interface for this destination is tunnel. Now what will happen? This is the packet. Maybe a router will receive this kind of packet from the user. This time router is going to check what? Destination IP. It will compare destination IP with routing table. So IP route 172.16.1.2, and you can see route is there in the routing table. To forward traffic to 172.16.1.2, route is available, and the network is directly connected, non-via connected, distance 0, matrix 0. But on which interface? On the tunnel interface. And guys, always keep in mind this: whenever router find exit interface is the tunnel interface, router will perform encapsulation. Router will perform encapsulation whenever router will find exit interface is tunnel interface. Can we see the packet header in the router? Yes, you can see the packet. Done. Whenever router find exit interface is tunnel interface, router is going to perform encapsulation. Right? Debug IP tunnel and see here what happened on the router. When I pinged to this IP address, what happened actually? Ping was successful, right? And this router was encapsulated your actual payload, the actual message, with GRE, encapsulated in another IP v4 header. And in the outer IP v4 header, source was 1.1.1 and destination was 2.2.2.1, which is what? Which is the tunnel source and tunnel destination. Tunnel source and tunnel destination. Why? Because exit interface was what? Tunnel interface. Even you can capture the link, right? And you can see the reply. Reply is decapsulated. When router 2 has generated the reply, source was 2.2.2.1 and destination was 1.1.1, and router 1 has decapsulated it. Encapsulated, decapsulated, right, with the GRE packet. Even you can do one thing, you can capture this link, because your traffic, all the traffic will go via physical link only, right? We cannot forward traffic through virtual link. See the capturing. If I am going to send ping and 2.2.2.1, right, my traffic is going from the physical interface. This time if router will compare destination IP address with routing table, so IP route is static, the destination will match in this route, and exit interface is physical interface F0/0, not tunnel interface. It will not perform any kind of encapsulation. Simply it will perform encapsulation at layer 2. It will add source MAC, destination MAC, and transmit the data from fast Ethernet 0/0, and your data looks like this. If you will open it, you can see actual ICMP payload, then IP header, Ethernet header, and then your frame, right, into bits. In the IP header, you can see source IP address 1.1.1, destination IP 2.2.2, and the protocol value 1, means payload belongs to ICMP protocol, and TTL value was 255. But if I am going to send traffic to ping 172.16.1.2, then you can see here is my data. Source IP and destination IP. Source IP is 172.16.1.1, destination IP 172.16.1.2. But let me open it, guys, for you. Open it. Data is readable in, it is in human readable language, right? We'll secure it. Now my actual payload is readable, right? Anyone can see my data. But most interesting thing is, again ICMP packet, then IP header, then GRE, then again IP header. This is what? This is outer IP header, right? ICMP packet, ICMP packet plus IPv4 header plus layer 2 header, Ethernet header, or we can say layer 2 header is the actual data, right? It was the actual data when you had ping to 172.16.1.2 to the destination. But what happened when router find exit interface is tunnel interface? When exit interface is tunnel interface, what router will do? Router is going to add one header where ICMP, then IPv4 is still there. Same IPv4 header. Now here router is going to add the GRE header and new IPv4 header. New IPv4 header, and after that layer 2 header, right? So router will perform this kind of encapsulation only when the exit interface is tunnel interface. Whenever router is forwarding traffic from tunnel interface, the router will not perform this kind of encapsulation if the exit interface is physical interface F0/0 or F1/0 or the VLAN interface. It is only for the tunnel interface. This particular thing is called GRE encapsulation. Now sometime interviewer can ask you the question that what will be the protocol value in this IPv4 header? This IPv4 header. Can you tell me in the chat what will be the protocol value in this IPv4 header, in outer IPv4 header? Protocol value. protocol value will be what? Here protocol value will be, guys, 40, which is the protocol number of GRE protocol. Now what will happen on the internet router? See, here I have router 1 and then internet ISP and then router 2. Router 2. On the internet, I am assuming some routers are there. And these routers have route for public subnet only. The router on the internet have route for public subnet. Private IP addresses are not allowed on the public network on the internet. So what will happen when internet router will receive the traffic? It is going to check layer 2 header. It will check the destination MAC. Destination MAC will be the MAC address of the receiving interface, because gateway is internet router IP, right? Then internet router is going to check this IP header. In this IP header, source IP address is what? Tunnel source 1.1.1.1, tunnel destination 2.2.2.1. This is the public IP address. Router will take forwarding decision based on this destination IP address. Here you can see this one, right? First router is going to check Ethernet header, then this outer IP header, source IP, public, destination IP, public. It will check destination IP 2.2.2. It will compare with routing table and it will forward from their exit interface. When this router will receive, again this router will forward traffic based on the outer IP header, source 1.1.1, destination 2.2.2.1. It will take forwarding decision. When router 2 is going to receive the traffic, router 2 will again check first layer 2 header, then outer IP header. In outer IP header, destination IP is 2.2.2.1. This is the IP address of router 2 itself, right? So traffic is for R2. Now R2 is going to check protocol value. Protocol value is 47. That means traffic is encapsulated with GRE. Router 2 will remove this header. It will open the GRE. It will remove GRE as well. And then it will check inner IP header. In the inner IP header, what is the destination IP address? 172.16.1.2. Yes, this is again my receiving interface IP address. It will check the protocol value. Protocol value will be 1 here in the inner IP header. So it will hand over the payload to ICMP protocol, and now ICMP protocol will generate reply. So here you can verify it. ICMP packet, you can open the outer IP header. You can see source IP address, destination, sorry, this is inner IP header. We should check from here. Ethernet header, type IPv4, very good. In the outer IP header, source IP 1.1.1, destination IP 2.2.1, tunnel source, tunnel destination. On R1, you can check. So run interface tunnel 1, tunnel source and tunnel destination IP. And then in the protocol, TTL value is same 255, and in the protocol field, what is the value? 47. 47 is the protocol number of generic routing encapsulation, your GRE. So all the router on the internet will be only checking this outer IP header to forward the traffic. Now these two tunnels are reachable from each other. But what about the LAN user, Praphul? What about the LAN users? Can this PC1 ping to PC number 2? So tell me guys, can PC1 ping to PC2? This PC is using IP, let's say 10.10.1.1, and this PC2 is using IP 10.10.2.1. 2.1. Can these two PC communicate? Again, if you are thinking yes, then type yes or Y. If you are thinking no, then type no. And yes or no? Yes or no? Just say ping will work or not between PC1 and PC2. Means 10.1, 10.10.1.1 and 10.10.2.1. Will ping work? Yes or no? Yes or no? In YouTube as well. Yes or no? So many people are saying yes, ping will work. But guys, let me show you the packet flow why ping will not work here. See, if this user is going to generate traffic, source IP address will be 10.10.1.1, destination IP will be 10.10.2.1, right? This PC will have gateway. It will forward traffic to their gateway. Router number one. Router 1 is going to compare destination IP address with routing table. So IP route and 10.10.2.1. Network is not in table, but there is one default route, so IP route is static. So destination IP address will match in this default route. Here is the issue. This is the issue. Why PC1 and 2 will not communicate with each other? This is the issue because destination is matching in the default route. If destination will match in default route, then exit interface is physical interface. And if exit interface is physical interface, router will not perform any encapsulation. Then router will not perform any encapsulation. And let me access PC1 and PC2. Let me configure one IP on PC, IP 10.10.1.1/24 and gateway IP address. Let me check the IP on router number 1. So IP interface brief, exclude and assign. IP over here is 10.10.1.254, the last IP address from the subnet, 10.10.1.254. And go to PC2 and let me check the gateway is reachable or not. 10.10.1.254. Gateway is not reachable. What happened here? So run interface f1/0. IP is 10.10.1.254. Submit mask is correct. From PC1, as it should be reachable then. So IP all. What IP? 10.1.1, 10.1.1.254. Yes, correct. Ping 10.10.1.254. We are not able to ping R1. Ping 10.10.1.254. I think interface is down. So IP interface brief exclude and assign. Yes, this interface is down. Let me up the port interface f1/0. Say no shutdown. And on router number 2 also. So IP interface brief exclude and assign. Okay, here interfaces are up. Now from PC1, if I will ping, then I am expecting reachability, and now you can see ping is working. Go to PC2 and let me configure IP 10.10.2.1/24 and 10.10.2.254, and let me ping the gateway IP address. Ping 10.10.2.254, and you can see gateway is reachable. But from PC1, if I am going to ping PC2, ping 10.10.2.1, you can see ping is not working, and in the capturing you can see router is not performing any encapsulation. It is forwarding traffic without encapsulation, and that's why I'm getting which error message here? Timeout error message, means reply is not coming. Default gateway has route, it is forwarding the traffic, but there is issue with reply packet. Why? Everything is in front of you. Router will forward traffic from fast Ethernet 0/0. It will not perform encapsulation. When internet router will receive, it will see destination IP address is 10.10.2.1 private IP address, internet router will simply discard the packet, right? It will discard the packet. This is the reason why these two private sites are not able to communicate with each other. Even you have created the VPN, but now you have to configure the route, right? What should be the exit interface on router number 1 for this destination? Tunnel 1, Praphul, tunnel 1, right? Exit interface should be tunnel 1 interface, not physical interface 0/0. And guys, if I will configure one static route here, let's say on router number 1, IP route 10.10.2.0 255.255.255.0 and exit interface is tunnel 1. Next hop IP address is 172.16.1.2. Then there are two routes, right? Destination is matching in two routes. Then one is default route and one is a specific route. Now router in the routing table of R1, one connected network is there, default route 0.0.0/0 and exit interface is F0/0. One is connected 10.10.2.0/24 and exit interface is tunnel 1 interface. Destination will match in both the entry in default route also and in a specific route also, but default route is not the preferred route, right? The last preferred route. If the specific route is not available in the routing table, then only router use default route. Otherwise router don't use default route, does not use default route. It doesn't use default route if any specific route is there, because in default route not any bits is matching and here 24 bits are matching. So now router will forward traffic from the tunnel interface, not from the physical interface. Hope it is clear. Guys, please confirm till here everything is clear. Is everything clear till here? Just type yes if everything is clear till here so that I can move. Now we'll see the static route and dynamic routing configuration over my VPN. Yes. Could you please repeat last one? Tell me best path selection on router. Best exit interface selection on router. The you can say best path selection criteria of router. Router first check what? Longest prefix length. Right? Router will always prefer the route where longest prefix length is matching, then AD value and then metric. Not AD value first. Right? AD value is the second parameter. So let's add the route here. As route is not there, it is ping is not working. Let me take you to router 1 and let me configure the route. IP route 10.10.2.0 255.255.255.0. Exit interface is tunnel 1 interface and next hop IP address 172.16.1.2. Now so IP route static. Now we have two static route here. You can see this time. Now if PC1 is going to ping, exit interface will be tunnel interface and it will perform encapsulation. Let me show you the capturing, and here again I am going to send traffic from PC1 to PC2, same traffic. Ping is still not working because of reply packet, but now you can see router is performing encapsulation, right? In the outer ID, outer IP before header, you can see source and destination both are public. Right? Now why ping is not working? Because of reply packet. Now ping is not working because of reply packet. So let me take you to router 2, and on router number 2 also I am going to configure one static route. Even to verify here, you can enable debugging, debug IP ICMP. Now my request is coming to router number 1, right? From PC number 1, if I am going to ping now the IP address of router 254, then you can see, let me take you to router 2. You can see it is router 2 is receiving ICMP request message. It is even generating the reply message, but in the reply destination IP address is private IP address, right? Exit interface is physical interface. Destination IP address is matching in the default route. On all config T IP route 10.10.1.0 255.255.255.0. Exit interface is tunnel 1 interface. Next up IP address is 172.16.1.1. And now go to PC1 and ping. Finally, you can see now ping is working. Now your two private sites are able to communicate with each other over public subnet, PC1 to PC2 as well. See, ping is working. And here you can see the encapsulation. If you will open any ICMP packet, you can see two IPv4 header are there. Guys, if 100 routers are there in the ISP network, if 100 routers are there, like I am trying to ask you this question, that if I will trace route from PC1 to PC2, will I discover internet router? Will I discover internet router? Answer is no, Praphul. Trace and 10.10.2.1. You can see my router R1 and then R2. R1 and R2. Traffic is going over VPN, right? So in the inner inner IP header, TTL value is still 255, right? When PC will generate traffic, TTL value will be 254. When router will forward from the interface, it will become 254, and on router number 2 also it will be 254 only, right? Internet router on the internet will decrement in TTL by 1 in the outer IP header, not in the inner IP header. And many time interviewers are asking questions from this particular topic, just to test your knowledge that you know the VPN or not. This is the foundation of VPN, the fundamental knowledge of VPN. Any VPN. No. Very good. Now what is the issue here? Now we have only one issue, that is plain text. Traffic is going in plain text, right? This is my company data. I cannot forward it like this. Anyone can read it very easily. Here you can see the trace route output, right? First it has discovered router number 1, then it has discovered router number 2 directly, right? Even if I am going to ping again from PC1 to PC2, ping 10.10.2.1, you can see here in the inner IP header, TTL value is what? 63. Windows PC generate messages with TTL value 64. So router has decremented it by 1. And here in the outer IP header, TTL value is 255. And if I will capture this link for you, this link between ISP and router 2, and send ICMP packet again. So you can see here, you can see in the inner IP header, TTL value is still 63, same. And in the outer header, TTL value is decremented by 1 on internet. That means on the internet, how many routers are there? 1. But in the trace route output, you can't find that. In the trace route output, you can't find that. Hope it is clear. Now, like you configure a static route here, you can also run the dynamic routing protocol. If you have lots of subnet in the LAN, like here you can see I have 2 LAN subnet, 192.168.1.0 and 10.10.1.0. In branch 2 also 192.168.2.0 and 10.10.2.0. So instead of adding all the routes manually, I can also configure here dynamic routing protocol. I'm going to remove the static route, do so run section, static route, or let me say IP route, and let me remove this static rod here. Let me say no to this one, no to this, go to router 2 and do so run section IP route, and let me say no to this. I've removed the static route. Again, PC1 cannot ping to PC2. You can see ping is not working. And now let's configure one dynamic routing protocol. Even in the last class, I told you that VPN can encapsulate all IPv4 packet, IPv6 packet, multicast packet, and routing protocol packet. So if I am going to run any routing protocol, let's say EIGRP router, EIGRPS number 10 and network, I'm going to enable EIGRP on tunnel interface 172.16.1.0 wildcard mask 0.0.255, no auto summary. Done. Now router 1 will start sending EIGRP hello message, debug IP EIGRP hello, debug EIGRP packet hello. It is sending EIGRP hello message, and what will be the exit interface for this hello message? So IP EIGRP interfaces, you can see tunnel 1, and again if the exit interface is tunnel interface, it will perform encapsulation. So in the capturing, even you can verify your EIGRP hello packet. Your EIGRP hello packet will also get encapsulated. Here is your EIGRP hello message. You can see actual hello message, then inner IP header, source IP unicast, destination IP multicast 224.0.0.10, and it is encapsulated with GRE. In the outer IP header, again we have same information, right? Let me enable EIGRP on router number 2 also, on all, and R2 router EIGRPS number 10, no auto summary, and network 172.16.1.0 0.0.255. And now you can see my EIGRP neighborship is up, right? So IP EIGRP neighbor, EIGRP neighbor is up on which interface? On tunnel interface, right? Q count is 0, sequence number is 1, RTO time is this one, SRTD time this one, uptime this, hold on time this. So now we have the EIGRP neighborship over my VPN, right? Now through this EIGRP, we can exchange our private subnet. Router EIGRP number 10, network 10.1.1.0, wildcard mask 0.0.255, and network 192.168.1.0, wildcard mask 0.0.255, right? So IP protocol routing is done for all the subnets, right? So IP EIGRP topology table, it have installed this subnet in the topology table. Why it have not show IP EIGRP interfaces? So EIGRP is not enabled on those two interface. What happened? So run section EIGRP. Oh, sorry, I have run the commands of R1 on router number 2. Do so run section EIGRP, and let me say router EIGRP yes number 10, no to these two commands, and no to, sorry, not this command, actually sorry, this command, this should be no, and this should be also no. 10. These are the LAN submit on router number 1, network 172.16.1.0 0.0.255, and here I will advertise network 10.10.2.0 wildcard mask 0.0.255, and network 192.168.2.0 and wildcard mask 0.0.255. And now so IP EIGRP interfaces, you can see EIGRP is enabled on all the interfaces tunnel F1/0 and loop back 1. And so IP EIGRP topology, it have installed all the prefixes in topology table, and now it is going to advertise to router number 1 through update message, and router number 1 will have these routes. So IP EIGRP topology, very good. So IP route EIGRP, you can see it has learned branch 2 prefixes on which interface? On tunnel interface. Again, exit interface will be what? Tunnel interface. Similarly, on router number 1, I am going to advertise the LAN submit router EIGRP as number 10 and network 10.1.1.0, 0.0.255, and network 192.168.1.0, while karma 0.0.255. So IP route EIGRP and router number 2. So IP route EIGRP. Very good. Here I have not received 10 submit. What happened? So IP EIGRP interfaces, it is not enabled on F1/0. Do so run section EIGRP 10 dot, sorry, by mistaken I have advertised the incorrect network. Router EIGRP 10 no to this, and network 10.1.0, 0.0.255. Very good. Now you can check router 2 routing table, and it is receiving both the LAN submit of branch 1, and branch 1 router R1 is receiving both the submits of branch 2 through EIGRP routing protocol, and exit interface is tunnel 1. Hope it is clear. So easy. Please share me the all configuration in WhatsApp. Sure brother, I will try my best. Done. Now again, if PC1 is going to ping, ping will work. Ping is working, and here you can see in the capturing. Now this is the only issue, that my traffic is in plain text. To secure it, what I can do, I can implement the IPsec here. And what I told you guys, for securing this VPN, now my VPN is not secure. VPN is providing connectivity between two private side over public network, no problem, but not secure. For the secure, what I am going to do, I am going to implement here IPsec. IPsec. In IPsec, we have two R1, R2, and in between we have internet. To secure it, we are going to R1, R2, and ISP. See, to secure it, guys, what I told you, security means what? I want to achieve integrity, authentication, and confidentiality. Means only authorized user should be allowed to modify the data, should read the data, should have the access, right? So we need to configure encryption. There are two types of encryption: manual encryption and the dynamic encryption. Here I am talking about the dynamic encryption, right? Then hashing, right, means adding the checksum value, and authentication. For the authentication, I can use again manual method or dynamic method. In manual method, manually you can configure pre-share key. Like on both router, I am going to define key Cisco 123, let's say, right? So with the help of key, both the routers can authorize each other that I am establishing the tunnel with the genuine router or not. For the encryption and hashing, for the hashing means just calculate the hash value and add it with your data to achieve the security, so that only authorized user can modify the data. Like even on the Google, there are so many tools. One is MD5, right? That is what? That is one kind of algorithm, MD5 calculator. If I am going to show you here, if I will put any data in this algorithm, any data, let's say I love you, and generate, it will generate a hash value for me. Here you can see the hash value. You often use this method while iOS upgradation in the network, right, to verify the image, the updated image which we have downloaded to upgrade our router operating system is modified or not, the file is right or not. But even if I am going to add one dot here in my data, right, any change will change the hash value, right? You can see now at last D1 here 37, and now I have added one dot here, and now again I am going to generate the hash value. Now you can see hash value is changed. Hash value is changed. Again, if I am going to add one number, if I am going to say change the data I love you to I hate you, if someone had changed the data on network, you can see my MD5 digest value is changed, right? So these are the algorithms we are using to secure our company data. For the hashing, I can use MD5. Similarly, for the MD5, we have SAS 256, right? And some other hashing algorithms are there. Similarly, for the encryption, we have DS, we have 3DS, we have AES, advanced encryption. I can use any one protocol for encryption. But problem is what? How I will share these all method with router number 2? How I will exchange these all method between router 1 and router 2? Because on the internet, hacker is there, right? Good people and bad people, attacker, hacker, those all guys are also there on the internet. If I am going to share these algorithms with each other, that here router 1 is telling to router 2, brother, I will use 3DS to encrypt my data. Now attacker can also know that, and they can also use that to encrypt the data. Even they can check your pre-shared key. So to secure the data, here we are going to create two tunnel. One tunnel to exchange our algorithm, these all algorithm, right? Node to exchange the data. This tunnel is not to exchange the data. This is phase 1. Phase 1. Phase 1. What is the purpose of this phase and this secure channel? Key exchange. Key exchange, right? To exchange the algorithm, negotiate the algorithm, pre-shared key, authentication method, hashing method, encryption method. And then once we will have the phase 1 secure channel, after that, through this secure channel, it is going to establish one more tunnel, that is phase 2 for your data. Your all data will go through this secure channel, not the first secure channel. This is for data exchange. This is for data exchange. Data exchange, we call it phase 2. To form dynamically phase 1 secure channel, we have a protocol called ISACamp, right? Again, ISACamp is not a protocol, this is a protocol suite. Multiple protocols are there, combination of multiple protocols, right? ISACamp uses IKE protocol to establish a secure channel. In IKE version 1, you are going to define many things, various things like encryption method, hashing method, authentication type, right? Group, lifetime, even the key. See, if I am going to send lots of data from router number 1 to router number 2, lot of data from router 1 to router 2 with single key, I have used single key to encrypt all the data, lots of data. Then attacker can guess your key. right? Attacker will capture the data and it will find a pattern, your pattern, right? That every time you are encrypting a into, let's say, at the rate like this, it can create the pattern and then it can decrypt your data. So we will not send lots of data through same key, single key, right? We want keys should be automatically generated after some time, right? That's why we have what? We have Diffie-Hellman. Diffie-Hellman. So through Diffie-Hellman, we will generate dynamic key, right? And through lifetime, we can define like after how long keys should be changed. Keys should change to encrypt the data, right? So IPsec is secure protocol, and in phase 2 you are going to configure IPsec protocol. Again, IPsec is not a single protocol, this is suite of protocol. So whether you are configuring a fully pure IPsec or IPsec over GRE, in both cases you have to configure IPsec in 2 phases, phase 1 and phase 2. Phase 1 to establish a secure channel, and phase 2 to send our data, to secure our data. Phase 1 is used to secure phase 2 channel, right, which is used to send the data. Let me tell you the configuration. It's very simple. Go to router number 1, and on router number 1 I'm going to configure phase 1 first, right? Before IPsec, you have seen my all data is in plain text. You can see the EIGRP data, everything. Now I'm going to configure ISACamp, and your all commands will start from the crypto for IPsec, because IPsec or ISACamp is what? Cryptography protocol only. If you know the cryptography, and if you want to learn the cryptography, in case if you don't know, you need to learn the security protocol, not the firewall course, right? The Palo Alto course or the FortiGate course or ASA firewall or checkpoint firewall will not teach you the cryptography, right? CCNP security course will teach you this. CCI security course will teach you this. So crypto, and then which protocol? Either you can configure IPsec, ISACamp, I can define the key, right? Various options are there. IKE version 2. If I am not defining the IKE version, it means I am configuring IKE version 1. For now, I am trying to establish phase 1 secure channel. So let me configure ISACamp protocol. Crypto, ISACamp, and then policy number, right? This policy number is like the priority. The lower number will be always prefer first, right? Like if multiple policies, ISACamp policy exists on your router, the router will look up which policy first, the policy with lower policy number. So let's suppose my policy number is 10, and here I can define the encryption algorithm. Encapsulation algorithm, you can see how many options are available on Cisco router. On the firewall, guys, on ASA firewall, you can have some more options. On FortiGate firewall or checkpoint firewall, you can have some more option. We'll see that as well in the FortiGate series. The FortiGate series, firewall series is going on my YouTube channel. There we'll see the VPN or IPsec configuration in detail, right? So here I am using AES because AES is the most advanced one here out of these options. So encryption protocol is AES, means by using AES protocol it is going to encrypt the data. Similarly, hashing, for the hashing I have, again you can see multiple protocol, MD5, SA, SA256, SA384, SA512. So let me use SA512 or SA256 will also work fine, okay? And then authentication method to secure any channel. Always keep in mind this point. This is very important to understand the IPsec. Always and always keep in mind that to form any secure channel, we need 3 things. To form any secure channel, we need three things: encryption, hashing, and authentication. Again, for the authentication, you can see pre-shared key manual method, and through certificate also we can define the authentication. Here I am going to say pre-shared, right? So we are done with phase 1 configuration. Now you can define the Diffie-Hellman group as well. Group, let's say 14, and then lifetime, let's say 1000 second, means after 1000 second it is going to change the key. Do so history. Here is my configuration. I'm done with the phase 1 configuration. Only one thing is pending, that is pre-shared key. Praphul, you have not defined the pre-shared key. Similarly, I can copy these all commands and I can paste it on router number 2 also for phase 1 configuration, means ISACamp configuration. Done. ISACamp configuration is done on both the routers, router 1 and router 2. Done. Now I need to define the pre-shared key. So let me take you to router 1, and here I am going to define the pre-shared key. Again, my command will start from crypto, ISACamp, and let me say key. What should be key? Cisco 123. And for which peer? Right, address. Peer address is 2.2.2.1. Even you can define 0.0.0, right, for all the peer. For this peer, I have defined keyword Cisco 123. Similarly, on router number 2 also, I will define the key for which peer? For 1.1.1.1. Remote site IP address, the peer IP address. Right, now you can verify it. So crypto ISACamp policy, you can see ISACamp, there is only one policy, right? Like this, you can have multiple policies. On router number 2, I can have one more policy, crypto ISACamp policy number, let's say 15, and here my encryption is 3DS, hashing is MD5, and authentication is pre-shared, like this, right? So crypto ISACamp policy, you can see on router number 2 there are two ISACamp policy. On router number 1 there is only one ISACamp policy. Now router 2 and router 1, both the routers are going to negotiate, right, the ISACamp phase 1 configuration, right? Like router 2 has two policy, first it will check this one, then it will check this one, right? The priority you can see, protection suite of priority 15, priority 10. If all the algorithms will match in this policy, then it is not going to check this policy. If let's say here I am using 3DS, and on router number 1 my encryption algorithm is AES, so if it will not match, then it is going to compare another policy. Until and unless it will not match font, it will be checking all the policies. Here router 1 and router 2 is going to form secure IPsec phase 1 with the help of this ISACamp policy, because all the encryption, hashing and authentication method is matching. Okay, phase 1 configuration is done. You can run few more commands for the verification. So crypto ISACamp key, you can check the key is Cisco 123, and the host name or address of peer is this one. You can also check the security association. What is security association? Security association is combination of these all security parameters, like your encryption, hashing and authentication. To create any secure channel, we need 3 parameters, and the combination of these 3 parameters is called security association. So crypto, ISACamp and security association, you can see. Now I don't have any secure channel here between router 1 and router 2. Wait for some time, let me finish with phase 2 configuration as well, right? We are done with phase 1 configuration. Now we are going to configure IPsec. Let me take you to R1. Right now router 1 is not sending any message, negotiation message. You can see IPsec negotiation message, nothing is there, because I have not enabled the IPsec on interface till now. Now here I am going to configure phase 2, guys. In phase 2, first of all you will configure transform set. Transform set. Question is, what is transform set, Praful? Transform set is a tool which will tells to the devices which encryption algorithm, which hashing algorithm to use to encrypt the user data, right? The data for phase 2, all the data in phase 2 is going to be encrypted, right? And which algorithm it will use for encryption and hashing, that will be defined by your transform set. Sir, instead of key, can we use type secret as well? Secret means where you can use the secret, brother. Wait. Now to configure phase 2, again crypto, and this time instead of ISACamp I am saying IPsec, and let me create one transform set. Name of my transform set, let's say PM, and then define the protocol for encryption. For the encryption in IPsec, we are using a protocol called ESP protocol, ESP. And EFC, what should be the encryption protocol? Let's say AES, to encrypt the user data. This is for user data. To encrypt the user data, what should be the encryption protocol? And guys, the encryption protocol in phase 2 and phase 1 can be different, right? In phase 1, whatever encapsulation protocol you have defined here, encryption protocol, same algorithm should be configured on router number 2 also. Similarly, in phase 2, whatever encryption algorithm you have defined here, that should be defined on router number 2 as well. And ESP for the hashing, I am going to use, let's say, MD5 or SA 256. Transform set, PM, name of my transform set, and then ESP protocol. Done. After that, you can define the mode. IPsec works in two mode, transport mode and tunnel mode. See, if you want to encrypt everything including data plus IP header, then you will use tunnel mode. Tunnel mode is going to encrypt complete data including the IP header, and transport mode will only encrypt the payload. My header, IP header will be visible, right? So I want to encrypt, let's say, only payload. Now you tell me what you want. You want to encrypt everything or you want to encrypt the payload only? If you want to encrypt the payload only, just type P. If you want to encrypt everything, just type E. E means everything, the complete data, and P for payload only. Let me see. EEW. Okay. E. Right. So let me use transport mode here. Right. It will only encrypt the payload. That's it. What is the difference between IKE version 1 and IKE version 2? There is huge difference, brother, right? Difference in terms of messages. For that, you have to go very deep in IPsec. You have to understand the messages, IPsec mode. Like I had told you, IKE version 1 works in two modes, main mode and quick mode. You have to understand the IPsec messages, right? Then only you will understand the difference between IKE version 1 and 2. By the way, there is one detailed video on my channel. You can watch that, right, to learn the IKE version 1 and 2. For now, let's focus here. Now, guys, we are done with our IPsec phase 2 configuration. Let me copy the command, do so history, and I am going to paste the command on router number 2 also from here. Copy router 2 config t, and let's paste it. All good. We are done with phase 1 and phase 2 configuration. To verify phase 2, again you can use command show crypto, and this time IPsec and SA security association policy profile. Even I have to create one profile. Transform set you can check. Security association you can check. Right now we don't have any security association. No SAS font. Now To apply the IPsec, here I am going to create one crypto map just to apply it on the tunnel interface. So say crypto map, and name of crypto map is 10, and then put question mark here. Let me see the option. Sequence number 10, and call your IPsec ISACamp protocol, ISACamp, and set the peer here. Set peer 2.2.2.1, and here I can also set the address. Set first transform set was PM, and here you can also match the address. Like if you want to encrypt only the data between these two LAN subnet 10.1.1.0 to 10.2.0. I don't want to encrypt the data of this subnet, these two subnet, right? These are general traffic, because guys, whenever router is going to perform encryption, it will use their CPU, right? So it is not necessary that in production you are going to encrypt all the data, right? Only critical data should be encrypted. So that in that case you can match the address as well. Match address, and then I can call access control list here. Access list number 10, access list number 100, or access list number 10. Access list number 100. It will match the traffic from access list number 10. In access list number 10, I am going to define the subnet IP access list 101 and permit, and let's say permit source IP 10.10.1.0 wildcard mask 0.0.255, and the destination 10.10.2.0 wildcard mask 0.0.255. Access list 100 permit IP done. And now we can apply it on the interface F0/0, and crypto map, and name of your crypto map is PM, right? So PM, that's it. Now you can see ISACamp is on, and now I am going to say no interface tunnel 1. This is pure IPsec. This is not IPsec over GRE. I have removed the tunnel 1 interface here. Go to router number 2 also. Here also I need to create one crypto map. So say crypto map, name is PM, number sequence number 10, IPsec and ISACamp. Set peer 1.1.1.1, set transform set PM, and set not set match address from access list number 100, exit access list 100, and permit IP 10.1.2.0, source 0.0.0, destination, oh sorry, here I think I have configured incorrect access list. Yeah, access list should not be like this. Say no here and say access list 100, permit IP 10.1.1.10.1.0 wildcard mask 0.0.0.255, and destination network 10.10.2.0 wildcard mask 0.0.255. Now it is correct. Similarly on router number 2, access list number 100, permit IP 10.10.2.0 wildcard mask 0.0.255, and destination 10.10.1.0 wildcard mask 0.0.255, and interface F0/0 crypto map, and name of your crypto map PM, right? And here also I am going to remove tunnel interface, no interface tunnel 1. Now PC1 and PC2 can communicate or not, guys? So IP route, now you can see we are not receiving any route through EIGRP protocol. There is no any tunnel, nothing on router number 2 also. So IP route. Again, if I am going to ping the destination 10.10.2.1 from 10.10.1.1, ping will not work But this time one interesting thing is there, right? Your traffic when 10.1.1 10.10.1.1 will generate traffic for 10.10.2.1. Traffic will match in your access control list. But when 192.168.1.0 user is going to ping, it will not match in access list. So these user 192 can still not communicate. See, from router number 1, if I am going to ping 192.168.2.1 and source 192.168.1.1, see, is ping working? No. And router is forwarding traffic from the physical interface without encapsulation. Nothing is there. But from the router 1 itself, if I am going to ping 10.10.2.254 and source 10.10.1.254, will ping work? Ping is working. And see, your data is encrypted. Before sending the data, you can see phase 1 ISACamp messages, right? It has exchanged some message. It has formed the IPsec phase 1 in which mode? In main mode. Here is the quick mode messages, main mode message and quick mode message. And when actual user forward the traffic, you can see my data is encrypted. You cannot open it. You can see how it's look like. Sequence summary is there. That's it. This is pure IPsec between two sides to send data, private data, our public network securely. But issue over here is you cannot configure routing protocol because guys we don't have any tunnel here. So IP interface brief. I cannot configure dynamic routing protocol in this case. We are forwarding the traffic, private traffic, with the help of access control list. Whatever traffic will match in ACL, router will forward it, right? Router know the peer IP address and their own source IP address. That's why you can see in every data source IP 1.1.1.1, destination IP 2.2.2.1. You have defined it, set peer, while configuring the ISACamp key and while configuring the crypto map. You have defined the peer IP. On the basis of that, it is performing encapsulation, right? And if you will set the mode, if I will change the mode here, go to router 1 and go to crypto. And one more thing guys, let's verify the ISACamp phase 1 first. So crypto ISACamp and SA security SA. Now you can see there is secure channel, status is active. This phase 1 will be not active always, right? After, what is the lifetime you have configured? 100 seconds. So after every 100 seconds, this secure channel will wake up, generate the key, exchange the key, again it will go for sleep. Again after 100 seconds, on the both router, wake up, generate key, public dynamic key, exchange the key and go for sleep. And phase 2, so crypto IPsec SA security association. Here you can see your phase 2. Peer IP address, right? If the source and destination will match in access control list, then your IPsec will encrypt the data and it will perform encapsulation with source this, destination this, right? Here while troubleshooting, this is very important. You can see detailed information about the packet, drop packet, error send, receive error, right? Various informations are there. And here you can verify the state also. Status is active, right? From PC number 1, if I am going to ping PC2, go to PC1 and ping PC2. Ping is working and see my data, how it looks, right? On the GRE also you had seen the data. In next class, if you will ask me to configure IPsec over, sorry, GRE over IPsec, then I will do that configuration also. Otherwise that will be also same, but benefit is there you can configure the routing as well, because you have the tunnel, you have the VPN. Here VPN is not visible, not manageable, we cannot manage the VPN. And now if I will change the mode, tunnel mode, what will happen? It will start encrypting headers as well. Okay, nice. Here access list, add. Yeah, we can add that also. Now here if I am going to say crypto, sorry, not yeah, crypto, and then IPsec transform set, what was the name? PM, and ESP was I think, let me check, it will be better. Do so run section IPsec, and here is my transform set configuration. Let me take you in this mode, and if I am going to change the mode here to tunnel this time, do so history, and let me copy it and let me paste it on router number 2 as well, the 2. And now if I am going to ping from PC1 to PC2, ping is still working, but this time you can see mm, 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 mm. Earlier this was your packet. We are not getting the as it is output here. Let me do one thing here, go to router 1 and exit tunnel mode, router 1 interface F0/0, let me say shutdown. And no shutdown from PC1. Now you cannot ping data, destination host unreachable. Say no shutdown, go to PC1 and ping. Now ping will start working. And now here in the Wireshark we are getting the same output, right? But the difference is in term of encryption, right? If you want to encrypt the entire data, you can use tunnel mode. If you want to encrypt your payload only, you can use transport mode. Someone said to add this as well in ACL 192. For 192, ping is still not working. Now I want to allow that as well. No access list 100, and go to router number 2 also. Or why I have removed the ACL? Simply I can add the ACL. Access list 100, permit 192.168.2.0, while karma 0.0.255, and destination 192.168.1.0, 0.0.255, and go to router number 1. Sorry, what happened here? Permit IP, and on router number 1 say access list, permit access list 100, permit IP 10.10.1.0, 0.0.255, and 10.10.2.0, 0.0.0.255. Access list 100, permit 192.168.1.0, 0.0.0.255, and 192.168.2.0, 0.0.0.255, and here I can add the IP is missing. That's it. Now show IP access list. Done. And now see, if I am going to ping 192.168.2.1 and source 192.168.1.1, again my communication will work, and you can see data is encrypted. Okay, sir. Thanks, sir. Permit IP. Most welcome, brother, and hope it is clear now, the GRE VPN and the IPsec VPN. Thank you, sir, for your time. Most welcome, brother. No problem. Okay. And now, if you are learning, if you are network engineer, make sure now you will configure it. Now it's your turn. Right? You have the recording. If you need to revise anything, forget about the theory at least. At least you should configure it in GNS3. I'm expecting you all have at least GNS3. Maybe someone don't have, you cannot have the EVNG, but GNS3 is very simple and easy simulation software. Every network engineers are using these two simulation software, Packet Tracer and GNS3. So let's configure it before next class, and the last class is tomorrow, right? In the tomorrow class, we are going to understand something really very important and very interesting as well. Okay, so make sure tomorrow you will join the class at sharp 9 p.m. at same time. Let me check. Bundle of thanks. CCNP, CCNA, CCNP combo live batch. Will you cover all types of VPN? Yes, in the CCNA plus CCNP live batch, will go very deep in these all types of VPNs. Whatever list of VPN I had shown you yesterday, GRE, IPsec, IPsec over GRE, right? And even in the IPsec, there are various types of VPN, and so many concepts are there. Even in the configuration, if I will use the question mark, there are so many ways. Here I cannot go in deep in each section, but in the live class, we'll go into the very deep in each and every section. Will cover each and every types of VPN there. Okay, so if someone is really passionate, dedicated to learn and master the combo course, CCNA plus CCNP course, this batch is starting from 18th of August, and timing of that batch is also 8 p.m. to 10 p.m. only. Bundle of thanks. Thanks, Praphul ji. Great lecture. Thank you. Most welcome, sir. Could you please provide the configuration in app config? Brother, for the configuration, I'm so sorry, I cannot give you the configuration here. I will check. I will definitely have commands of IPsec somewhere. I will share that in your WhatsApp group. But for the PDF, definitely I will share. Sir, I am studying from the Bangladesh. I really like your classes. Thank you so much. Most welcome, sir, and thank you. Thanks a lot for sharing your feedback. IPsec seems difficult. No, IPsec is very easy, right? After learning, when you will learn, and then if you are going to, if someone is going to ask you, tell me the name of your favorite VPN, I'm damn sure you will say IPsec only. IPsec is the most interesting and most easy types of VPN. When I had not learned the SD-WAN, I was thinking SD-WAN is the complicated technology. But today, if you will ask me, Praphul, which one is your favorite technology? Answer is SD-WAN only, because it's very interesting. I love SD-WAN. So, sir, I want to implement the same following, but GNS3 installation will error in the, why you are uploading GNS3 over VM? It is not required. You can run it on your machine, local machine directly. Thanks. Welcome, brother. Devendra. Devan. Done. Can I get access to the lab to try hands-on? No, you cannot access our lab. You can set up it in your laptop. What would be the next day? Tomorrow is the next class. Thank you, very useful. Thank you so much, Chandu. Many thanks. Love you, sir. Love you too, brother. Thank you very much. And how much do you charge for SD-WAN? I charge 25,000 for SD-WAN. Sir, fee and duration of CCNA plus CCNP combo has been not be been shared yet. So fee will be shared to you by my team member, or you can visit to my website pmnetworking.in, pmnetworking.in, right? Whatever fee is there on the website, that will be the fee only. I am not providing any discount. If there is discount, that will be for everyone, and it will be visible on the website, right? So don't ask for discount and those all things. We are not we are same for everyone, for all the student. For all the student, fee is going to be, duration will be 3 to 4 months depending on the students. More than 10 student has already enrolled in the course, right? So the duration, exact duration will depends on the students. If all will be the working professional, because I know most of will be the working professional, network engineers only, more than 80%. But even if single fresher will be there in the class, then I have to go from the very sketch, even sometime from below CCNA, right? So in that case, it can take some more time, maybe 4 plus month, right? But 3 to 4 months is sufficient to for me to cover NANP. And thank you so much, MD Abu. बारिश कर दिया आपने तो लव का. Great. SD-WAN classes are running right now. The last weekend I have started one SD-WAN batch. Even I have covered the SD-WAN components only in that batch till today, right? So next class is on the Saturday from 8 p.m. to 10 p.m. where I am going to start the implementation of SD-WAN, right? So if you want to learn, if you want to join my SD-WAN batch, yes, you can join it. You can cover the previous 2 classes through recording. We will provide you the recording of that. Okay. Now, bye bye guys. That's all for today. Thank you so much everyone for joining. Let's connect tomorrow and we'll talk more.